let's get started. So for the first question, part A, we want to find the z transform of En. Okay, so the capital E z, which is z transform, we have the equation for that. So we're going to sum and start from actually this is from negative infinite to positive infinite for e to the order of negative an un, and you just multiply with the original one, which is this one, put in here, multiply that with a z to the order of negative n. Okay, and we can make this one start from n equal to 0 because we have a un here, step function. So we have this from 0 to positive infinite, e to the order of an z negative n. Okay, so we can start, n is looping from 0 to positive infinite for this term. Okay, so this capital E z, we can extend that, start from n equal to 0. N equal to 0, this one equal to 1, this one also equal to 1. 1 times 1 is 1. Okay, for n equal to 1, then we got a e negative to the order of negative a, z to the order of negative 1, and that's it. Okay, and plus e to the order of negative n 2, z to the order of negative 2. Okay, so if we can put them outside, put that order, take a 2 outside, it's become like this. Okay, so you can have, we have the same thing to the order of 3, 4, all the way to e to the order of negative a, multiply with z to the order of negative 1 to the order of n. Okay, so change the color. So this one actually is a geometric theories. All right, so you can see there's a pattern there. The general form for the series look like this: is a plus ar plus ar square plus dot 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 all the way to arn minus 1. Okay, so to this, and for that we got this one equals to a 1 minus r to the order of n, okay, over 1 minus r, and we have a so we have n is not equal to 1. Okay, r is not equal to 1, so not make the bottom 0, and when n is approached to infinite, so we have all kinds of, if just n equal to 3, then that's not the case. Okay, if n goes to infinite, so the Sn just equals to a over 1 minus r, and this r has to be larger than negative 1 and smaller than positive 1. Okay, this is a region of a convergency for this one, so this one gonna converge to a number. Okay, if e, for example, r is 2, then it's not a number, it's go infinite. Okay, so only when r within this range, we got Sn, this whole thing equal to this one. Okay, so this is something we maybe you learned from some other class. Okay, so let's look at our case. In our case, we have ra actually equal to 1, right? So a, the first term is 1, so every term there's no coefficient at the front, so a equal to 1. And what is r here? R is actually just equals to e to the order of negative a, z to the order of negative 1. Okay, so r in this condition, so there is a condition for that, right? So this r, the absolute value of r has to be smaller than 1. So if r is this, then we make we know that a to the negative a e to the order of negative a magnitude has to be smaller than the absolute value of z. Okay, because this one just e to the order of negative a over z. Okay, z just the z to the power of negative 1, just make it to the denominator. All right, so this two thing, this like fraction number smaller than 1, so the upper one has to be smaller than the denominator. Okay, so yeah, so we can have the final result for that. Let me scroll down a little bit. So we're gonna just using this one. Okay, using this one. So the final result, Ez just equals to a is 1, right? And 1 minus r is that. Okay, and we have a we can move terms like this. We can move the z here, and minus e to the order of negative a. Okay, so there is ROC. The region of convergence is z has to be larger than e to the order of negative a. Okay, that's the same thing here. Okay, that's the part A. Actually, if you use the table, if you use the z transform table, you will find where is that? You will find there is an equation. If you look at the table, there is an equation like this: a to the order of n un. If you do a z transform, that's the arrow. Okay, you do a z transform, you got it this one: z to the order of z minus a. Okay, so in this case, it's not just that. Okay, it's actually if you look at the question, is e to the order of negative a. Okay, this is look like e to the order of negative a and to the order of n un. All right, so if you put this one to replace this a, then you will get exactly the same result here. Okay, cool. So that's the first part.